Okay, we're going to start with our notes for 6.1, slope fields and differential equations. We're going to start with our first skill in example 1 is how to verify the solution of a differential equation. So as you can see, we have y equals e to the negative x as our function we're starting with, and we have to verify the differential on the right, which is 3y prime plus 4y equals e to the negative x. So I'm going to start off finding y prime over here on the left, and y prime would be e to the negative x times negative 1. So y prime would be negative e to the negative x. I'm going to go over here to the differential equation on the right, and I'm going to substitute in both y prime and y. So 3 times y prime, which is negative e to the negative x, plus 4 times y, which is e to the negative x, and I'm going to keep the right side of the equation as e to the negative x. I'm going to try to get this left-hand side to equal the right-hand side. Negative 3 e to the negative x plus 4 e to the negative x equals e to the negative x, if I clean it up a little bit there. Now I can simplify my like terms of e to the negative x by adding the coefficients. Negative 3 and 4 is 1 e to the negative x. And as you can see, we got that to match with the right, which is e to the negative x. So very simply, we are done. We have verified that we have verified the differential equation on the right here. In 1b, it's a similar type problem. Looks a little bit different. They use a dy dx in the place of a y prime, and we have to show that dy dx is equal to xy over y squared minus 1. So I'm going to go back over here to the left, and I'm going to find y prime, but I'm going to have to use implicit differentiation. So 2y times y prime minus 2 times the quantity 1 over y times y prime is equal to 2x, because remember, with implicit we differentiate both sides of the equation with respect to x. You could also substitute a dy dx in here for y prime. Now I'm going to simplify these two terms on the left. They both have y prime in them, so I'm going to leave them on the left. So I have 2y prime minus 2y prime over y is equal to 2x. I'm going to factor out y prime. I'm left with 2y minus 2 over y equals 2x. I'm going to go over here to the right, and I'm going to divide both sides by the quantity 2y minus 2 over y, and I end up with 2x over 2y minus 2 over y. Now we're getting there, but we didn't show that dy dx and y prime are the same. So what I'm going to do is I'm going to multiply the top and bottom of the right hand side of y prime by y. So I'm going to multiply by a y here and a y there, and I get y prime is equal to 2xy. Y times 2y is 2y squared. Y times 2 over y is a negative 2. As you can see, I've gotten a little bit closer to xy there to what we have in the original. I'm going to divide out as a GCF a 2 from the denominator, y squared minus 1, and I'm going to divide out the 2 from the numerator and denominator. I end up with xy over y squared minus 1. So with just some algebraic manipulation, you can see that we matched the differential equation to the one we are trying to verify, and voila, we are done. So we're going to move on to the next topic, which is, move that out of the way, using integration to find the general solution to each differential equation. So we've mentioned this a couple times. We have this idea of separating variables. So I need the y's and dy on one side and the x's and the dx on the other side. So I'm going to multiply both sides of this equation by a dx, and I get dy is equal to x cubed minus 4x, that quantity times dx. I'm going to use integration to integrate both sides of the equation, the left and the right. The integral of 1 with respect to y is y. The integral of x to the third is 1/4 x to the fourth minus 4 over 2 x squared plus c, because we are finding a general solution. going to simplify that. Y equals 1/4 x to the 4th minus 2x squared plus c. And we are done. Example 2, part B. I'm going to do the same thing by multiplying both sides by dx, and I get dy is equal to x e to the x squared dx. Integrate both sides. I end up with y on the left-hand side. Remember that we're not going to put a c on both sides because they would subtract out, so we're just going to keep it on the right-hand side with the x's for now. And on the second one, this is a substitution question, so u is equal to x squared, du is equal to 2x dx, and we have an x dx, but we don't have a 2x, so I'm going to multiply both sides by a half. So I get 1/2 du is equal to x dx, and when I plug it back in and rewrite it in terms of u, I have a 1/2 du that's going to take the place of the x dx, and e to the u, because the u takes the place of the x squared. So our integral is now 1/2 e to the u du. So as we know, that's 1/2 e to the u plus c. Bring down my y. Y is equal to 1/2 e to the x squared plus c. Just check it over, and that is the correct answer for this one. Okay, the last one on the front page here. Move the dx over to the other side through multiplication. And then I'm going to multiply the y to both sides. So y dy is equal to 1 minus x dx. Okay, so we had a little twist to this one in that we're integrating y dy instead of just 1 dy. And we have separated the variables, as you can see, y dy and 1 minus x dx. So now we're ready to integrate. The integral of y is 1/2 y squared. Again, we're going to keep the c to the right-hand side here. The integral of 1 is x minus 1/2 x squared plus c. There it is there. Now we're going to multiply both sides by 2. Let's assume we're going to solve for y here. So y squared is equal to 2x minus x squared plus 2c. Again, we multiplied both sides by 2. Solving for y, we get y is equal to plus or minus the square root of 2x minus x squared plus 2c. And there we have it. We've solved for y, and we have used integration to find a general solution to this original differential equation, whether it's dy dx or y prime, really treat it the same way. Moving on to the back side of the notes is just a couple of slope field questions, so we'll just spend maybe hopefully 3 or 4 minutes tops working through these. So you are given a differential at the top. You're given 9 points, which they sometimes will do on the AP exam. We're going to have to draw small line segments that represents the slopes of the function y at these 9 points, and our slopes are determined by the differential equation for y, which is above here. So I started with the point in the top left, -1, 1. I plugged -1 in for x, 1 in for y, and I got y prime is equal to 1 plus 2, which is equal to 3. So the slope here at -1, 1 has to be 3, which is pretty steep. So 1, 2, 3. I'm going to say something along those lines. I just continued down, -1, 0, and I get a slope of 2 once you plug it in. So I'm not going to plug every point in for the sake of time, but all I'm doing is plugging these x and y values into the differential. Get a slope of 2, which is a little less steep than the one before, at -1, 1. Now I'm going to use -1, -1. I got a slope of 1. Moving on to 0, 1 has a slope of 1 as well. 0, 0 has a slope of 0. 0, -1 has a slope of -1. Moving up over here, I have the point 1, 1 has a slope of negative 1. 1, 0 having a slope of negative 2. And the last point of our 9, 1, negative 1 has a slope of negative 3. Down 3, a little bit steeper. And there you go, a slope field for the differential y prime equals y minus 2x. And again, remember, these slopes represent the slopes of the function y at those particular points. Let's move on to the second, our final example in our notes. Y prime is equal to y plus xy. And again, I'm going to go through this fairly quickly and not write down quite as much. So negative 1, 1, if you plug it in, you're going to get a slope of 0. Negative 1, 0, slope of 0. And negative 1 is also a slope of 0. So 0, 0. I'm going to move to the 3 points in this column here. I'm going to start with 0, 1, having a slope of 1. 0, 0 has a slope of 0. 0, negative 1 has a slope of negative 1. So a slope of 1 here, slope of 0 here, and a slope of negative 1 there. And then the last 3, 1, 1 has a slope of 2, 1, 0, slope of 1, and 1, negative 1 has a slope of negative 2. And keep in mind that I just took these x and y values and plugged them into the differential to get the slopes. So I have a slope of 2 here, a slope of 1, a little less steep, and a slope of negative 2 right there. And that is our last example. Thank you for following, and I will try to make all these videos right around this time, in the 12 to 15 minute range.